Unit 1, Lesson 2.1b, Identity Theft. We're going to talk about chemical properties of matter. So we are on pages 28 and 29 of your guided notes, which are your textbook pages. So remember that the vocabulary words are probably good things to highlight as you're reading your textbook pages. So a chemical property has to do when something changes to a new substance. So if I took a tomato and I smashed it, it's still a tomato. It was tomato when it was regular shaped, and when I smashed it, it's still a tomato. So those would be physical characteristics. But if I took that tomato and I ate it, in my stomach, that tomato is going to undergo chemical changes and provide nutrients for my body. An example that we had with physical changes was Play-Doh. So some of the physical characteristics that I could see would be this yellow, it's smushy, smells doughy. But if I took a piece of this Play-Doh and I put it in water and left it there for a year, part of this Play-Doh is going to dissolve. And so it's going to go from this Play-Doh that I can play with to being a dissolved substance within the water. So it's actually going to change its chemical properties. It's going to break down into the individual components that the Play-Doh makes up. And so when you're looking for the difference between a chemical property and a physical property, just remember that a chemical property is when something changes its identity. It changes into something else. So if I decided to bake double chocolate chip cookies, I put all my stuff in my blender, the flour, the eggs, the vanilla, the chocolate chips. I blend it all up really good. It has some physical characteristics. I can stick my spoon in it. It's easy to manipulate. I can taste it. It is pretty tasty, but I probably don't want to eat a lot of it because it'll make me sick. It has chunks in it. And if I take that and I put it into little globs on a cookie sheet and put it in the oven and turn the oven on, the heat within the oven is going to cause chemical reactions to occur in my cookie batter. And so as it bakes, it's going to make a new substance. So the cookies are going to change from just this cake batter to there's going to be this magic that happens, and they're going to turn into cookies. So read through your information on page 28. And then on the bottom of 28, you have a predict statement. And the predict statement says, why do automotives rust more easily in wet climates than drier climates? And if you don't know what it means by rust, that's when something, when exposed to the air or water, gets this reddish, crusty color on it, caused by oxidation. So pause the video, answer question number 28, and then come back when you're ready. When you're looking at this question, when it's talking about wet and drier environments or climates, for example, in the desert, it's very dry, very little humidity. So you can go to the desert, sweat, and it'll almost evaporate almost instantaneously. Versus here in Georgia, in August, we know all about humidity. The air is very heavy. It has a lot of water vapor in it. And so areas that have a wetter climate have a higher humidity. So chemical properties are when something changes into something else. Some things to look for: is light emitted? Is there an odor? Does something precipitate? Means if I have a liquid, I pour in some stuff, something starts to fall out. Does it catch on fire? Those sort of things. Is there an odor produced? So one of the chemical characteristics is reactivity. So if I put salt into water, it's going to dissolve. And so it's going to go from a solid salt to being dispersed into the water. Still salt, still water. But if we took baking soda and we put it into some vinegar, we're definitely going to see a reaction. The same thing happens when you take a Coke bottle and you put a Mentos in it. A chemical reaction occurs. Some things that we notice that a chemical reaction is occurring is that we have bubbles, we have this gurgling that happens, and so that's evidence that something's going on. In this example, when the baking soda is being put in, you can see those bubbles, and those bubbles are probably carbon dioxide being given off, which means the baking soda is being broken down into something different. So on the picture on the upper left, you can definitely see that something different is happening. And we can see this by the expansion and the change of the things that were added together. On the bottom is what we mean by a precipitate. That when we add this silver nitrate, we start to get this precipitate, or this brown gunky looking stuff in the liquid. And then in the upper right, you see that when we add things to this, we can definitely see that a chemical reaction is happening. The first liquid, we get a color change. The second layer, we get that gas that's being put off. And I bet there would be an odor if we were sitting there. So all these are evidence that something's happening to change the chemical identity of the substance. Burning is an example of a chemical change. When wood burns, you get a light that's given off. You also get heat. And so both of those things indicate that bonds are being broken within the molecules in the wood to provide the energy to produce the light and the heat. If we could capture what the gases coming off of the wood, one of the main gases that we would capture would be carbon dioxide. Carbon dioxide is one of the things that's given off when most organic things are being burnt. Some other example of chemical properties are toxicity, oxidation states. Some of these words you're probably not going to see this semester. But these are words to start getting familiar with now, and so when you get to high school, they won't be foreign to you when you get there. And so in your guided notes, I would like you to place a list of those chemical properties underneath the picture of the strawberries on page 28. And you can see that I've titled my list chemical properties off to the side and underlined it. And that's the end for this set of slides.